Today we're joined by a friend who needs no introduction, but whenever somebody says they need no introduction, of course that means they're going to give them an introduction, and that's Professor Avi Loeb, who is not only one of my favorite individual scientists, but he's one of my favorite human beings. How are you doing today, Avi?
I'm doing great. Thank you so much. It's a special day.
It is. It is really special. The new year, and in the Hebrew calendar, at least, Shana Tova, all of our Jewish friends and non-Jewish friends out there. Avi, it's been an incredible summer since we first started talking about this majestic, mysterious object that some say is possibly alien technology. Some say it's ordinary, prosaic meteors or comets, and we even have some meteorites. I'll be giving those away later. Stay tuned for that. But Avi, first things first, why is today so special? What happened today with respect to everybody's favorite interstellar object, 3I Atlas?
What's special is that a picture is worth 1,000 words, and we are about to get images of 3 Atlas that are the best resolution ever, simply because it comes so close to Mars. Now, it will be difficult to observe it during the month of October from Earth because the sun will be between us and the 3A Atlas, perhaps for a reason. But it comes today closest to Mars within 29 million kilometers. And there are orbiters around Mars that could look at it. For example, the HiRISE camera on board the Mars Reconnaissance orbiter that NASA put near Mars can take images and with a spatial resolution of 30 kilometers per pixel, and that's the highest yet for 3A Atlas. We don't know how big the nucleus of 3A Atlas is. I wrote a paper last week that showed that it must be bigger than 5 kilometers because we looked at more than 4,000 observations from 227 observatories around the globe that monitored 3A Atlas over the past 4.5 months. And we put the motion of 3A Atlas on the sky as a function of time, compared it to what is expected from a trajectory that is sculpted just by gravity. And we found no difference whatsoever, meaning that we can put a very tight limit on any non-gravitational acceleration. And that means that the object is very massive because we do see that it's losing about 150 kilograms per second based on the Webb telescope data. And it's mostly coming in the direction of the sun, from the sun-facing side, because the Hubble Space Telescope took an image that showed a jet 10 times longer than it is wide coming in the direction of the sun, of scattered sunlight. And so altogether, that should give a recoil to an object if it's low mass. But the fact that we haven't detected any recoil, any deviation from a gravitational trajectory, means that the object is very massive, more massive than 33 billion tons. And for solid density, that means bigger than 5 kilometers. That's bigger than the width of Manhattan Island. But it could be much bigger than that. It could be up to 46 kilometers in diameter based on the SphereX data that was obtained a couple of months ago. And so we don't know what its actual diameter is. And of course, the mass scales as diameter cubed. So it's really important to use the brightest pixel in the HiRISE image to infer the surface area that is reflecting sunlight of the nucleus of 3A Atlas. So that's coming up. And then there is also the high resolution stereo camera on board ESA's, the European Space Agency's Mars Express. That's expected to capture lower resolution images. Then we have the color and stereo surface imaging system, CASIS, on board ESA's ExoMars Trace Gas Orbiter. And again, we will get color images here and also stereo views, helping to learn about the composition analysis through spectroscopy. There is also a spectrograph on that mission. And then there would be ultraviolet imaging that could be obtained from the MAVEN spacecraft that NASA launched near Mars. And there would be additional images reported probably from the camera on board China's Tianwen 1 spacecraft, as well as the Hope orbiter of the UAE's Emirates Mars mission. So lots of instruments, and obviously data is the best way for us to figure out the nature of this object, because as you often say, Brian, you don't judge a book by its cover. We saw some gas around this object that came from the skin of the object. We shouldn't assume that what lies inside is dictated by what we see coming from the skin of the object.
Now, you said something very provocative in the very beginning. I can't let that go. And you said there we won't be able to really observe it from Earth at its closest approach. And you said perhaps there's a reason for that. Now, this may or may not venture into a techno signature discussion. So, first, why did you say that? And second of all, how close will it get to be, to the Earth actually?
Right. So to the Earth, it will not come very close because we are on the other side of the sun right now. So the closest it will get is in the middle of December, just before Christmas. And at that point, it will be more than double the Earth-Sun separation. So it never gets close to Earth if it follows this path. However, if it's a technological object, it might maneuver, taking advantage of the gravitational assist when it comes closest to the sun. So when it gets closest to the sun, if it's a comet of natural origin, it might erupt in a flare of outgassing and maybe even break up into pieces of ice. However, if it's technological, it might maneuver. And then if it comes on the other side of the sun in a completely different trajectory, I think the financial markets may crash. Now, let me say a few words about what we believe to be the anomalies of this object. So, like in any blind date, encounters with interstellar objects can result in deal breakers, meaning non-negotiable behavior. And I separate the anomalies of 3i Atlas into two classes: those that could be alleviated or explained away with upcoming data, let's say from the Mars orbiters, and those that will never go away. They will remain puzzling forever. So let's start with those that might be clarified. First, the size of 3i Atlas, as I mentioned, should be larger than 5 kilometers. We don't know what it is. However, if the images indicate a much smaller size, less than a kilometer, then this tension of why are we seeing an object that is 1,000 times more massive than the previous interstellar comet, Borisov, from 2019, that would be alleviated. It's also 1,000,000 times more massive right now than Oumuamua, the first object. So, it's just puzzling. Why would the third object be so many orders of magnitude more massive than the previous ones? And then there is the jet that I mentioned, that is another anomaly, 10 times longer than it is wide, pointing towards the sun, very different from the tail that we often see away from the sun in solar system comets. And then there is the unusual chemical composition. The plume of gas around 3i Atlas is showing much more nickel than iron. And we find much more nickel than iron in industrial production of nickel alloys. So the question is this a techno signature? Again, we can learn more as we do some spectroscopy when it's close to Mars. And also, unlike solar system comets, the plume contains mostly carbon dioxide and not water, as many astronomers forecasted that this must be water rich. It's not water rich. Water makes only 4% of the mass budget of the plume of gas around it, the coma, and 87% is carbon dioxide. And then there is polarization of light from 3i Atlas, which is extremely negative, never seen before for comets from the solar system. All of these are physical characteristics that could potentially be explained.
You
But
dive
then
into the
there
polarization.
are,
That's how I butter the bread around the Keating household is polarization. Explain what is polarization, why it's the least understood form of all the light properties that we know about: spectrum, intensity, polarization, and almost nobody knows about it. And yet, it's incredibly important for revealing compositional details. So, you should explain to the audience what is polarization and why is that so significant, what you just mentioned.
Yes, in fact, I discussed polarization in the class that I teach at Harvard to graduate students. It's the only obligatory class in the PhD program of the astronomy department at Harvard, and it's about radiative processes in astrophysics. And last week, I discussed polarization. Polarization is any electromagnetic wave is basically made of an electric field that is oscillating and a magnetic field that is oscillating, and the two fields are perpendicular to each other in vacuum and perpendicular to the direction of motion. Now, the magnetic field can be related to the electric field, so we just need to discuss the electric field, and because the two are always perpendicular, and the electric field could it's moving. So if you were to move with it, then you could see it, for example, oscillating up and down along an axis. That's called linear polarization. And it could also move in a circle. The vector of the electric field can move in a circle, and that would be circular polarization. And then you have combinations of the two that give you elliptical polarization. And there is also the possibility of no polarization at all, where you mix all kinds of polarizations in a way that you don't get any polarization. So the fraction of the light that is either associated with an electric field along one axis is or a circular polarization gives you the polarization fraction, or the level of polarization of the electromagnetic wave. And that is important because, for example, if light is being scattered by electrons, then it depends how the electrons are moving when they scatter the light, and they produce polarization to the light if they have some geometry. And that's not true only for electrons, it's also true for any scatterer of light. And what often happens is, if the geometry of the scattering material has some shape that is not spherically symmetric, you end up polarizing the light in a preferred direction. And what we see for 3i Atlas is negative polarization, which is very extreme. And perhaps nobody worked out the details. It might be related to this geometry of the jet that I mentioned, of scattered light, scattered sunlight in front of the object towards the sun. We don't know it because nobody worked out what can explain this polarization. Never seen before for comets. And then I should mention there are anomalies that will remain puzzling forever, irrespective of how much data we get from the Mars orbiters or from other probes. The trajectory of 3i Atlas is aligned with the plane of the planets around the sun to within 5 degrees. And that has a likelihood of 0.2%, less than a percent. And so the question is, why is it aligned? If you imagine incoming objects from outside the solar system, they should not have a preferred direction. They come in all angles. And in fact, the previous two interstellar objects had a large angle relative to the plane of the planets. The plane of the planets, the ecliptic plane, is not in the same direction as the disk of the Milky Way galaxy. There is no reason for an incoming object to be so perfectly aligned. And of course, it's very fortunate for us because it means it spends a lot of time near assets that we have in space. Like it's coming close to Mars, and then it's coming close to Venus, and then it's coming close to Jupiter. That allows us to look at it in great detail because it's also a big object. So it's our fortune, but why do we have that fortune of 0.2% likelihood? The arrival time of 3i Atlas is also optimized for it to pass near Mars, Venus, and Jupiter, because these planets are moving around the sun, on a period of other years, and yet 3i Atlas comes to the right place at the right time to be close to all three of them. It doesn't come close to Earth, though, and again, one may ask why. And then finally, just this week, a few days ago, I realized that the arrival direction of 3i Atlas from the Milky Way galaxy into the solar system was coincident with the direction of the WOW signal. And that's a radio signal detected on August 15th, 1977. And it was a complete mystery where this signal came from. It's called the wow signal because that's what the person, the observer who noticed this signal in a Ohio State University observatory, the Big Ear, just noticed an amazingly strong signal, much above the noise. But and it was clear that it's extraterrestrial, coming from outside the Earth. But it wasn't clear where it's coming from within the Milky Way galaxy. And what I realized by comparing the coordinates of where the signal came is that they are within 9 degrees of the direction from where 3I Atlas came. And 3I Atlas back in 1977 was about 600 times farther from Earth than the sun is, and about 3 light days away from Earth. And so the chance of it being aligned with the wow signal is 0.6%. I calculated that. And at that distance, if you ask how much power is needed to emit such a radio signal as detected, it comes to about a gigawatt, the power output of a typical nuclear reactor on Earth. So,
And
you know,
that wasn't
with
just at that wasn't at some random frequency, right? That was at 1420 megahertz, correct?
yes, very close to the hydrogen hyperfine transition. And also the signal was blue shifted. So it means the source was moving towards the sun, just like 3I Atlas. The inferred speed was about 10 kilometers per second. 3I Atlas was moving at 60 kilometers per second, but it could be related to some measurement error. Also, it didn't come from exactly the same direction. So, another possibility is that it was a signal transmitted towards 3I Atlas from another source. But this leads me to recommend to radio observers to monitor 3I Atlas for any radio signal. As far as nothing was reported so far, as far as I know. But I wrote an email to some people hoping that they will actually observe 3I Atlas in the coming months with radio
It
observatories.
should be possible. I mean, we could observe it even with things like the Simons Observatory. But tell me, Avi, why, when you put all these together, I think it's quite interesting that I don't believe you concluded the wow signal alignment improbability as an anomaly, or did you?
Well, I just realized it a few days ago, and I
Yeah.
now added it. So altogether, there are 7 anomalies.
Yes.
Now, dogmatists that insist on 3I Atlas being a comet of natural origin, they should be held accountable to explain all of these anomalies as results of probable natural processes. I mean, very often they say it's a comet and stop at that, but it's not enough to just say what it is. You need to explain how come all these low probability features of 3I Atlas are being realized. And, we should remember the story of the Trojan horse, where an innocent looking visit delivered an existential threat to the city of Troy. And, there is this wager, very famous wager that Blaise Pascal used to argue that we must consider God seriously, even if we believe that the likelihood for God's existence is small, because the implications of this notion are huge. And I argue the same about the technological origin of an anomalous interstellar object like 3I Atlas. Encountering an interstellar artifact could constitute a black swan event with a low probability but major implications for humanity. And so, actually, earlier this week, just 2 days ago, I submitted a white paper to the United Nations, suggesting to establish an international organization that will attend to this possibility for all future interstellar objects. So we will evaluate the data, the scientific quality data, coordinate observations, and decide what to do, how to respond if there is an anomalous object that could not be explained as a natural one.
Wow, that I can't believe how. I always say you're the most optimistic pessimist that I know, Avi, but an Israeli proposing to the United Nations that they should do something. I mean, this is
Okay.
the triumph of hope
Well,
over.
I'll tell you why I did it, because I was on a Zoom call uh, in a group discussion with General Stavridis, and I actually asked him, the United Nations was established less than a couple of months after the end of the Second World War, exactly 80 years ago, in
Yep.
October 1945, and I said, look, this organization is not functioning very well, doesn't have teeth, and should we reboot the United Nations? And he responded that there used to be, before the United Nations was established, the League of
League
Nations,
of
which was
Nations.
much less effective. And the United Nations is indeed it doesn't have much teeth, but it's the best we have, and it's really difficult to establish something even better. So he's suggesting to improve it, not to remove it and establish something new. And that might be true. I do believe that there is a lot to be improved in it, but at the moment there is no other international organization that I can appeal to establish a committee that would evaluate interstellar objects. I think it's really important because we are all in the same boat, all humans on Earth. If we have a visit of alien technology, the aliens don't care how we split the land on this rock that we happen to be born on. Who cares? Like, from a large distance, the entire of Earth looks the same. And so we need to think about this kind of a threat or interstellar science in a global way, in a way that
Mm.
involves all nations. And that's the nature of science, by the way. And I told the General Stavridis I'm coming from the world of science, where international collaboration is the fundamental fabric of science, where I can go to any country in the world and speak with astronomers there, and we all speak the same. We all have similar interests, and therefore, for science matters, what lies outside the solar system, it must be an international organization that
Yeah.
deals with that. Matters of nations are all about national security, and that involves objects that belong to this Earth, that pose a threat. And that's what, for example, the Space Force is dealing with. But anything to do with objects from outside the solar system should be discussed by all humans, irrespective of which nation they come from. Um, we lost your sound, by the way, Brian.
What about now? Do you hear me now?
Yes, I can
Okay,
hear you.
good. So we had a discussion right before we went live about the presence of the Perseverance rover, which is not in orbit. It's on the surface of Mars. It's been looking around. So there's an interesting post that you share with me from Blue Sky, which I spend almost a negative amount of time on. But this is from someone named Simeon Schmaus. Schmaus. I don't know how to pronounce that weird beta-looking term at the end, but some German out there is screaming at me, which reminds me to tell people my two favorite words I used in my quantum mechanics class today come from German, and they are Ansatz. When you feel really happy, you say, "That's an Ansatz for an equation." And then my other favorite is, do you know how to say ambulance in German, Avi?
No.
Krankenwagen. So if you're sick, Avi, we will take you to the Krankenwagen. So that's
Well,
my German.
Brian, 50% of my DNA is German. That's from my
Yep.
father's side. The
Nobody's
reason I'm
perfect.
alive
No, nobody's perfect, Avi. Me too,
no, no,
actually.
no. I should say the reason I'm alive is because my grandfather had the wisdom of living Nazi Germany in 1935. So he was
Wow.
really smart. 65 members of the family decided to stay, and they said, "We will live in the last train." They were optimists, and they left in the last train, but it led to concentration camps.
That's right. They say the optimist went to Auschwitz and the pessimist went to New York, Israel, and but it's
Exactly.
sad to say it looks like there's some scary similarities. But we're not talking about politics today. Let's talk Perseverance. Perseverance rover from Simeon Schmaus on Blue Sky, STEM3 on bluesky.social. I think Perseverance might have spotted an interstellar comet 3I Atlas last night from Mars. After stacking 20 images from SCAM-Z, he found a faint smudge of light in the constellation Corona Borealis, the northern hare, the northern crown, close to the location where the comet was expected. Avi, tell us about this. What is the implication of this, and how bright is Atlas now, and what is the percent polarization? Because we have some telescopes we built out here in San Diego. We might be able to catch it as well. So how bright is the comet, and what percentage polarization is it currently?
Right. So the comet is relatively bright from Mars. It's about the 11th magnitude, and uh, you know any any camera bigger than 10 centimeters should be able to capture it. The problem is that the Perseverance rover is was designed to look at the surface of Mars, not find the comets in the sky, and it's not optimal. So we are just seeing a small smudge, and it's not really helping much for the science. But as I said, the HiRISE orbiter that moves around Mars will do an amazing job. And I was communicating with the principal investigator, and he promised that they will do their best. And
Yeah,
so
we
I'm
tried to
sure
get
that,
him on, Alfred. We tried to get on Alfred.
yeah,
Yeah, we tried to get him on today. He was not available for this call,
right.
but hopefully we'll get him back after they've had some time to take the data. What will it?
Exactly. So
Yeah,
they probably have some data. ESA probably has some data. They just didn't release it as of yet. And it really depends on the research team as to how quickly we'll have access to it. It might be a matter of days or a matter of weeks, depending on how long it takes them to process the data. The other effect is obviously that of a government shutdown in the US that may actually suppress the study of the data coming from the Mars Reconnaissance orbiter.
so if it does see something, and when we do actually get the data, and it has to be declassified or released pretty quickly, what are you first looking to do with that data once it's
Right.
available to you and your team?
Yeah, the first thing is to look at the brightest pixel, and that should correspond to about 30 kilometers at the distance of 29 million kilometers of 3i Atlas from the HiRISE camera, because this is a camera with a half a meter diameter, so you can easily do the math for the resolution. And I did the math, and it's 30 kilometers per pixel. So 30 kilometers is not much bigger than the estimated size of 3i Atlas. So one pixel, the brightness of that pixel could tell us how much sunlight is reflected from the surface of the object. Once we know that, assuming an albedo, a reflectance coefficient, we can infer the area.
Mm.
And, and then from the area, take the square root and get the size, the diameter of the object. And that would be a very tight constraint on the actual size of the nucleus. And if it's bigger than 30 kilometers, we might have more than one pixel represented. Uh, One thing to keep in mind is the plume of gas or dust or whatever is around the object is transparent. It's optically thin. There is no concern that we cannot look through it. And so my hope is we will get a very tight limit on the size and therefore the mass of 3i Atlas. And that could either exacerbate the discrepancy with the previous comet, 2I Borisov, or you might weaken it if it turns out the size is less than a kilometer based on the amount of light. Then we can then say that there is no tension with the amount of mass associated with this object. The other tension that I worked out is if the object turns out to be bigger than 5 kilometers, bigger than 10 kilometers, then there is just not enough rocky material in interstellar space per unit volume to deliver such a giant rock to our vicinity over a decade period. You expect it to arrive once per 100,000 years or 10,000 years, but not over a decade. And so that's another tension that led me to say the diameter must be less than a kilometer if it's a natural rock. But if it's bigger than that, then we need to explain that.
Yeah, indeed, we
Oh,
do.
and I didn't answer one question that you
Yeah.
asked me about polarization. So it's about minus 2%, the minus 2.5% polarization, negative, but it's considered extreme in comparison to known comets from the solar system.
Hmm. Wow, that is impressive. So, speaking of planets in the solar system, I did an episode earlier this year with Michael Brown of Caltech, who is a renowned observer. And that episode, Avi, I haven't won the Nobel Prize, right? I don't know if you're aware of that. I don't really talk about it that much, right? Everybody out there. But I am eligible to win a Signal Award, Avi. So, what I'm asking everybody to do, if you've gotten any value from the Into the Impossible podcast, go to the first link in the video description down below or in the chat. There's a pinned chat for the live chat. And or if you're watching this later, I'll put it in the pinned chat as well. It's only until Tuesday, which is also Red October. I don't know. We'll talk about Red October. We'll talk about Soviets. We'll talk about the Chinese space program. And my friend Chris Hadfield, who was just on the podcast, he has a new book. I want to talk about that. But beforehand, we have a gentleman's agreement, gentle ladies agreement. If you've gotten any fun or value out of me talking to Avi throughout the years or any of the other guests like Mike Brown and 22 Nobel Prize winners, including winner of the medicine or physiology Nobel Prize, Dr. Lou Ignarro. Do you know what Lou Ignarro won the Nobel Prize for, Avi? He won it for inventing Viagra. Okay, so he's responsible for a couple of different types of things that go erect in the night. But go to this website, please, if you like it. It's called a Signal Award. It's not the Nobel Prize. Click on this side over here. It says Brian Keating, Mike Brown. This episode could win one of the top podcast of the year, which would be a huge thing for me. I started this as a hobby. I love having on my genius friends like Avi and so many others, like the 22 Nobel Prize winners. And Fields medalist Terrence Tao is coming. He was on the show. We recorded at his office in UCLA last month. That's coming out this month. So please, if you got any value, I do ask only one thing. It's free. All you need is a very special email address because they will ask you to verify it to cut down on spam and bot. Okay, Avi, now back to the
Brian,
discussion.
let me just mention, since you mentioned um, him, so the last time I met him was in my office, and we were talking about objects in the Kuiper belt because that's he's famous for discovering those. And I asked him a simple question, which is related to 3i Atlas in a way, because I said, among all the Kuiper belt objects that we know about, have you ever checked the following? An object can either reflect sunlight, in which case its brightness declines inversely with distance to the fourth power, simply because the amount of sunlight that is impinging on the object declines inversely with distance squared from the sun. And then we are located at roughly the same distance from the object. So there is another decline by 1 over distance squared between the object and us.
Right.
So altogether 1 over distance to the fourth. And then if the object produces its own light, we would expect a decline with 1 over distance squared. Okay, so we can tell if there is a spacecraft generating its own light in the outer solar system, in the Kuiper belt, or just an asteroid reflecting sunlight by looking at how the object changes its brightness as it changes its distance from the sun. A very simple way to do that. And I wrote a paper about it with Ed Turner from Princeton in 2012. So I asked Mike Brown and I said, did you ever check whether the Kuiper belt objects that you know about, that you have data for, change their brightness inversely with distance to the fourth or distance squared? And he said, why should I check? It's obviously 1 over distance to the fourth. Now, the reason I bring this up is because observers, very often miss the opportunity to discover something new. We back in 1952, Otto Struve said, if there are planets like Jupiter close to stars like the sun, we can detect them. And observers ignored that suggestion. They said, we know why Jupiter formed so far from the sun, and we don't. That's the snow line, water snow line.
Right.
So back then there was a theory that now is regarded as wrong, because now we know there are Jupiters close to sun-like stars, and in fact the Nobel Prize was awarded for that. And at any event, for about 43 years, no such observation was reported. And then, of course, in 1995 it was. So between 1952 and 1995, nobody really paid attention to Otto Struve's proposal because the observers said, We don't expect that to exist in nature. Therefore, we shouldn't waste any telescope time searching for it. And then when they found it, the Nobel Prize was given. Now, the reason I bring this up is when you assume what you might see and therefore you don't even check it, you might miss the Nobel Prize. Okay, and how what kind of a waste would it be just to check that? Like the discovery of 1995 could have been made decades earlier if
Right.
anyone would pay attention to Otto
Mhm.
Struve. And I also checked the paper that reported the discovery by Marcy and Quilloz, and they didn't reference Struve. They were not aware of it or just didn't regard that proposal as important. But when they made the discovery, it was not even in their mind to refer to Otto Struve. So that
Mhm.
shows how science is very often inefficient, because people like Mike Brown say we don't need to check if an object in the Kuiper belt changes its brightness inversely with distance to the fourth, because they believe it must be so. And maybe they missed a spacecraft or
Right.
an object that produces its own light.
People
So
forget
I,
the second part of Reagan's famous claim that you should trust, but you should verify. Right. So they're doing the
yeah,
trusting, but they're not doing the verification. I
well, but
wonder. Yeah.
if you allow yourself to make a Nobel Prize worthy discovery, you must go in directions that nobody tried before.
Mhm.
That's a simple logic, right? But instead, if everyone follows the same path, nobody takes a path that is different, that doesn't believe theories. Here I'm recommending not to believe theories,
Yeah.
because theories, just give you the reasons for why you shouldn't observe this or that. You shouldn't believe theories, because sometimes nature is more imaginative than theories.
All right. Now, since we talked in September and July before that, in September we spoke with our friend Michael Shermer, who may join us. He may not later on. We'll see. But critics have been, kind of always quick to want to attack you, as I fear, and as I feel. There's a Yiddish proverb that says, the higher you fly, the easier you are to shoot down. So you
Yeah.
fly pretty high. You fly pretty close to the sun, but you back it up with hundreds, if not thousands, of citations and deep research and just an unquenchable curiosity. And I think that's the most magical quality about you. The criticism, not of you, but of the object, has been that, well, it has a tail like a comet. That to me, if I had to kind of handicap things, that might be one of the things that would concern me if I thought it was possible technology. What is the latest on the tail and its
Right.
orientation? And will it not flip around if it is a comet? Would that be conclusive evidence if the tail flips around as it moves to the outer solar system?
Yeah. So in July
I
and
should sorry.
August,
One more. Sorry to interrupt.
yeah,
Can you explain why comets have tails and what they tell
yes.
us about the comet, please?
So a comet is a rock that has an icy surface, and as it gets close to the sun, the ice gets vaporized. It doesn't have an atmosphere, so there is nothing to, for example, bring water to a liquid form. So the water evaporates, and as a result of that, the comets often release also dust particles from the surface, along with the water ice vapor, and um, uh, and those dust particles scatter sunlight. And as a result of them scattering sunlight, if they have a size comparable to that of the wavelength, they are very efficient at scattering sunlight. But they are also uh, pushed back away from the sun by the same radiation that they scatter, and you end up with a tail behind the object as it approaches the sun, and that's the signature of a comet. Usually there is a tail of dust, and if the dust is coupled to the gas, then the two appear together, or they could have different structures, because in principle they don't have perfect coupling, the gas and the dust. It depends on how much dust is released, how much gas is being released. But at any event, this is the origin of cometary tails. And what was true about 3I Atlas during July and August is clear from the Hubble Space Telescope image. It shows an elongation that is towards the sun. It's an anti-tail, and that is almost never observed for comets. There is perhaps one example, but the point is that in the Hubble image, we were looking at it from an angle of 10 degrees, because the object was at around 3.8 times the Earth-Sun separation. So we were looking at it roughly from the direction of the sun at an angle of 10 degrees relative to the direction to the sun from the object. And that means that in the Hubble image, we see an elongation of about a factor of 2. But if you correct for the sine of the angle, you need to divide by the sine of the angle to account for the projection. Then you end up with an extra factor of 5.7. That's 1 over the sine of 10 degrees. And that means this elongated feature is actually a jet that is 10 times longer than it is wide. And that is, and also if you look, there is nothing in the back. So the width is roughly how much it extends in the back. This glow is spherically symmetric around the object, except in the direction of the sun, where it's 10 times longer than it is wide, sort of like a jet, a real jet. And nobody tried to explain that jet, except a paper that we wrote with a colleague of mine, Eric Keating. So here is one additional anomaly. Why is there a jet that is 10 times longer than it is wide? Nothing like that was seen ever, that elongated, in any other comet. And that remains to be explained. So when someone says, I've been working on comets for many decades, and therefore you should believe me when I say that this is a natural object, you should ask that person, okay, we believe you, but can you explain the jet 10 times longer than it is wide for this object, very different from comets in the solar system? Then at the end of August, there was an indication by the Gemini South Observatory.
I'm showing that
of,
now on screen. I'm showing the
yeah,
Gemini spectra, the spectra across it.
so then we, for the first time, noticed a tail behind the object, perhaps related to some dust being released from the object, behaving in the way that dust should, and that is just a matter of the radiation pressure pushing it behind the object. But the amount of mass being released by the object, if it's indeed bigger than 5 kilometers, is really tiny. This entire glow around it, and as well as the plume of gas that was detected by the SPHEREX Space Observatory out to 350,000 kilometers. The amount of mass that you have in this plume of gas, mostly carbon dioxide, amounts to ablating about a millimeter thick layer over a period of several months from this object of that large size. It has such a huge surface area that the amount of gas observed is really nothing. It's just the skin of the object being evaporated in the direction of the sun. And so, as I said before, this may not tell us what the nature of the object, because any object passing through interstellar space, passing through interplanetary media, since it's freezing out there, may collect materials along its path, and that's what we see. But what it's made of is not necessarily the same material, because if it's 5 kilometers, just compare the outer millimeter to whatever the object is, it may be something different. So we need to continue to observe it and learn more about it. If it's a real comet, natural origin, it may break up, it may erupt. It should erupt, when it gets very close to the sun. And there is the JUICE mission that will observe it just after it passes closest to the sun on October 29th, and it will give us a lot of information. Now, I just wanted to mention a few points about what you said, that I'm being attacked and so forth. I have a huge amount of positive feedback that I'm getting. Just to give you a few examples, I was interviewed just a couple of hours ago on Newsmax, and the interview after me was with the deputy of the chief of staff for policy at the White House, and he was asked, is President Trump being briefed about the 3A Atlas, the anomalies that Professor Loeb is discussing? And he replied to that. So that's interesting. Another example, I received an email just 2 weeks ago from a former pilot in the US Air Force who said, because of you, my daughter now wants to be a scientist. And and that is the highest reward that I can imagine. If I can inspire young kids to become scientists, this is great, irrespective of whether 3i Atlas is a rock or not. This discussion by itself is attracting young kids to science. And another example, there is an artist from New York City that makes bronze sculptures. He is the most accomplished sculptor in the US right now, and he made two sculptures that he's donating to my office of Galileo, plus 50 watercolors that he will bring to my office. So
Well,
my office.
I'm going to get you the finger puppet though. Does he have a finger puppet? And I'm going to get you a meteorite,
Oh,
which, by the way, I give out to all of my guests that have a .edu email address. Go to briankeating.com/edu, and you live in the U.S., you'll get one of these babies right here. Now, last time I was really fascinated about the nickel, and the composition of it. Has there been any resolution since that discussion about the chemical composition?
So there was another paper just a couple of days ago about the nickel, and they say it's extremely unusual to see actually nickel, given the surface temperature of 3i Atlas. You won't expect it because you won't expect the release of uh, minerals, refractory minerals that would bring nickel into
Mm.
view. And they say the nickel to iron ratio is extremely unusual. They put it on a plot in comparison to other comets from the solar system. And again, that's an anomaly. They mentioned the carbonyl pathway, chemical pathway for making nickel without iron. That's the pathway being used by industries that make nickel alloys. And my question is this a techno signature? If you had an object with a surface that was manufactured technologically, would you expect nickel without iron the way we see? So again, this needs to be explained. It's not at all clear. There is no theory that accounts for it. We know that we make nickel without iron industrially. So all of these, make the object anomalous, interesting. Even if it's natural, we should find an explanation to these
Mm.
anomalies. And the other thing I wanted to mention is in 2 weeks, I was invited to a NASCAR car race because one of the drivers that competes there decided to put 3i Atlas with my image on the hood of his car. And I'm going to watch him. Now, it's quite possible that he will be in the middle of the pack, not really win the race. But nevertheless, how often do you see astronomy represented on the hood of a NASCAR car racer? That should be fun.
Now, before this event, what would you have considered the probability of the WOW signal being extraterrestrial intelligence? And I do want to point out that we have 3,500, 4,000 people listening, watching right now. And I want to take questions from. I'm going to take questions from all of them. So you're all going to get called upon out there. But in all seriousness, we will take your questions in just a bit. Before this discovery, which again is a serendipity on top of a serendipitous discovery, right? I mean,
Right.
you only found this out. Nobody else was looking for this. No one else has the kind of creativity and imagination that you do. But what did you think the WOW signal was? I mean, it's in this
Yeah.
waterhole
So
region. What did you think it
it,
was?
it was very puzzling because it's a real signal, definitely of extraterrestrial origin. And back then, when it was discovered, 1977, Carl Sagan highlighted it, and
Yeah.
people discussed it seriously. Now, last year, over the past year, there was a re-examination of the interpretation of the signal. And so, in an attempt to explain it as a natural source, the claim was made that we are seeing the hydrogen hyperfine transition. So perhaps it was hypothesized in that paper that was just published. They said perhaps there is a cloud of gas in interstellar space made of hydrogen that was illuminated by a flare from a highly magnetized neutron star, so a magnetar. And the flare is in the radio so bright that it pumps the hydrogen atoms to emit as a maser at 21 centimeters. So we're seeing a maser emission from a cloud of hydrogen being pumped or induced to generate maser activity at this transition, and because it's a flare, thing disappeared after a while, and we couldn't see it again. So that was their attempt to explain
This is
the wow.
Abel Mendez, right? This is Abel Mendez.
Exactly, exactly. Now, they said flatly in the paper that it's a hypothesis. We don't have any evidence for it. And for many decades, astronomers were thinking, well, maybe it is of extraterrestrial technological origin, because the idea was one way to communicate is through this line of close to the line of hydrogen, so then you can transmit communication signals uh, in an otherwise natural frequency. And so people, for example, we are mapping the Milky Way galaxy at 21 at this hyperfine transition, and so observers working around this transition could find the signal. And it's a very fundamental transition, actually discovered at Harvard University in the physics department. It was theoretically predicted by van der Hulst, and then a few years later, there was an attempt to measure it, to observe it in the sky. And so there was a horn antenna that was put out of a window of an office in the physics department at Harvard. And then they detected, amazingly, the hydrogen hyperfine transition from the Milky Way galaxy. It was a very bright transition, easily detectable. And the amazing thing is that at the time, there was a competing team in the Netherlands led by Oort that was attempting to detect the same transition. And remarkably, in a gesture of a gentlemanic quality, the Harvard team explained to the Dutch team why they are not detecting it. They had something wrong in the instrumentation. They corrected it and found it. And then the two papers appeared back to back in Nature, the discovery of this transition. And now, of course, it's being used as a tool to map hydrogen throughout the galaxy, but also throughout the universe, because hydrogen is the most abundant element.
Yeah, and so the hyperfine transition, you might just want to explain that it has to do with the possibility for spin of hydrogen's electron to be aligned or anti-aligned with the nucleus spin, correct?
Yes, so the electron has either spin up or spin down relative to the proton in a hydrogen atom. And then, the transition from parallel spins to anti-parallel spins has an energy difference that is very small. It corresponds to a wavelength of 21 centimeter. I was among the theoretical cosmologists that pioneered the use of this line to map the hydrogen in the early universe before the first generation of stars broke it into its constituent electrons and protons. And now, of course, we're trying to detect that signal. It was not discovered yet, but it would be a way of mapping matter in the universe, hydrogen in this case, in 3 dimensions, very different from the cosmic microwave background, which is giving us a map of the inhomogeneities in the universe in 2 dimensions, from the photosphere that made the universe transparent 400,000 years after the Big Bang. So mapping the 21 centimeter line allows us to do tomography in 3 dimensions, because every redshift corresponds to a different wavelength. It's 21 centimeter times 1 plus the redshift, that the wavelength that we observe. So by observing different wavelengths, we can actually map the structure of hydrogen in the universe in 3 dimensions, and get a much tighter limit on cosmological parameters as long as we find this. Now, the problem is that after 1 billion years, the universe lost most of its hydrogen because the first generation of stars produced ultraviolet light that broke the hydrogen into its constituent electrons and protons. And So we need to go back in time, less than a billion years after the Big Bang, and then we can map the hydrogen. That's very challenging because the signal is very faint. There is a very strong foreground from the Milky Way galaxy that is obscuring the cosmological signal, but nevertheless, there are several teams trying to measure it. And about 20 years ago, that's when I did many calculations motivating the search for this signal.
So last week, or maybe it was 2 weeks ago now, I interviewed your Harvard colleague, Steven Pinker. And Steven's got a new book out called When Everybody Knows That Everybody Knows That Everybody Knows. Sort of about this thing that I know, that you know, that you know, that I know, et cetera, et cetera. Like they used to say about the Soviet Union, we know that they're lying. They know that we know that they're lying. We know that they know that we know that they know that they're, so et cetera, et cetera. And it's kind of this infinite regress. And we talked about it in the context of Galileo, who, as you know, was from your late great colleague Owen Gingerich, was permitted to teach heliocentrism. Sorry, he was permitted to study heliocentrism, but he was forbidden to teach it. So the Siderius Nuncius is written in Latin because nobody spoke Latin. It's like LaTeX. You could do LaTeX, and you're probably, your gardener doesn't understand it, although my gardener's pretty smart. But you weren't allowed to teach it in the common parlance of the day and the place, which was obviously Italian, and that's why the dialogo, obviously an Italian word, was forbidden, and that got him on the index, and that got him banned and put in house arrest for the last 9 years of his life. By the way, we're coming up on the 400th anniversary. In 2032 is the 400th anniversary of the Dialogo. But Avi, tell me, in the context of common knowledge, in other words, the church was basically saying, we know that you're right, even though he was right for the wrong reason. We'll get into that in a second. But Galileo was right. We know that you're right, and the people know that you're right, but you can't tell other people lest that become common knowledge. Do you ever feel like that with the relationships that you have with Congresswoman Anna Paula Luna?
Luna, yeah.
Yeah, do you feel like there is or is not more favorable kind of treatment of scientists, possibly heretics, and whistleblowers now when it comes to the UAP phenomenon, or are we basically back in a 2020s version of 1642?
Well, that's really an interesting question. And as a scientist, what matters is really the evidence, okay? And I haven't seen classified information that would inform me of what the government really knows. And that's why I said, well, I can wait for the government to inform me, but that may be like waiting for Godot. It may never come. And also the government is mostly occupied with national security concerns, and they don't care much about the frontiers of science. So that's why I established the Galileo project, which aims to see if there's anything unusual in the sky. And by the way, I should mention we have now 3 observatories. The latest is in Nevada, and just today we are finishing the 3rd unit. So we have 3 units within that observatory in Nevada that would allow us to triangulate and measure distances to objects in the sky so that we can infer their velocity, their acceleration, and check whether they lie outside the performance envelope of human-made technologies. Because there are lots of drones in the sky, but they move at a limited speed. And so I approach this subject the following way. I say, I'm just like a kid. I don't want to believe stories that the adults in the room are telling me, whether the adults in the room are, mainstream scientists, or at least they claim to be such, or the adults in the room are politicians. I don't care what they say. If there are objects from outside of this earth, we should be able to see them, and we can collect our own data, either through our observatories, or the Rubin Observatory will observe those things irrespective, and then we go through the data and see, like, for example, there are claims, maybe there are satellites of the earth that do not belong to any nation. And I say, well, if that's the case, intelligence agencies should have seen them. And by the way, the Rubin Observatory will see them. So, you can't fudge your way out of data or evidence. The worst thing you can do is not seek the evidence. As I said before, not look for a hot Jupiter near a sun-like star, not look for whether Kuiper belt objects have a brightness that depends on 1 over distance to the fourth or 1 over distance squared. So if you don't check your assumptions, you will always live in ignorance. And that's what the Vatican preferred most people to know, not to be aware of what Galileo was doing, and not to be doubting the doctrine until 1992, when they admitted that he was right. And so you are entirely correct that this is a game of psychology that you can play as long as the data is not obvious. And you can hide the data, you can suppress the data. Reviewers and editors. I can give you examples of 3i Atlas. I submitted a paper for publication, and the last sentence was, this trajectory that it takes and its size are so anomalous that perhaps it was the trajectory was designed by some technology, some intelligence, and the editor insisted that I remove this sentence, or else the paper will not be accepted for publication. And that to me sounds like censorship. A single sentence like that doesn't do any harm to science. You can argue that you can prove it wrong easily by detecting all the cometary signatures around such an object, and then we are done. And who cares if there is a sentence or not? But the editor felt the need to remove it. And that editor went out and made public statements at the New York Post about any consideration of a technological origin is, nonsense on stilts. Again, this is aimed to intimidate any person who thinks outside the box, that wants to deviate from the beaten path. And I see that as causing damage to innovation in science. You want to allow people to think differently, because maybe one of those ideas will end up being correct.
Yeah.
And we are losing efficiency if we ignore those possibilities. As I mentioned before, the hot Jupiters could have been found decades earlier. So unfortunately, we see this phenomena that was practiced by the church during Galileo's time. We see it today among editors, among reviewers of papers. And when people say, well, this idea was not actually peer reviewed, keep in mind that some of the time the editors do not even send it to peer review because they have a prejudice. And it's really unfortunate, because nowadays, it doesn't cost any paper. Things online, are relatively cheap, and why not allow the community at large to evaluate the idea by itself? And I simply think that there is a lot of herding within our community that is suppressing innovation. And just look at the public. The scientists often in the mainstream argue we should not communicate with the public until we know the answer. Then they go on a press conference and lecture to the public what they think is the truth, as if these are students in a class.
Yeah.
But the public doesn't like that,
No,
because the public enjoys the process of science, where we have a lot of uncertainty to start with, and then, like in a detective story, you keep finding more and more clues that lead you in the right direction. And I see that clearly from the response of the public to the development of evidence on 3i Atlas. The way I communicate it is that it's work in progress. The public loves that. And so the scientists who are opposed to communicating with the public are causing damage, because what they are portraying science as is an occupation of the elite, where we only communicate to the public where everyone agrees and we know the answer, as if it's textbook material. But guess what? In many cases, there were answers given to the public that ended up being wrong. Okay, and it's just a false narrative to say that science needs to maintain its posture by not communicating the process to the public, because I think people connect to the fact that it's a learning experience, that we don't always know the truth, that we learn it by iterations, that we could be wrong sometimes, but then evidence brings us to the right view.
Yeah, there's a lot of also, we always have to balance the anti science with the conspiracy theories. I mean, now we have people like Tucker Carlson, Candace Owens. I have a video takedown of them coming out soon, but really kind of leveraging, oh, well, COVID, well, we were lied to about lab leak origins and the efficacy of the COVID vaccine. Therefore, we shouldn't trust science at all. I don't trust science at all, according to Candace Owens, actually uses a Wi-Fi transmitter. That's the byproduct of Bell Labs, which is where the CMB was discovered and lasers were invented. But
Yeah, yeah, yeah.
I don't want to go too far down that road, but I do want to
No, no,
bring
but
in.
that's very bad. I completely agree with you.
Yeah,
And I think the best path forward is actually to explain how science is done, that
yeah,
it's based on evidence, not prejudice, not stories. You don't believe eyewitnesses. You
yeah.
just follow data that instruments give us without any, wishful thinking. And That's the way science should be done without prejudice.
Mm-hmm.
And I think that the public understands that, and it appeals to the public. So there is a narrative that should be adapted, and it will improve the way that the science is being portrayed, because it's fun. It's supposed to be fun
It
when we
is.
don't know something, when we take risks rather than pretend to know the answer in advance, when we make mistakes. It makes us human. Any learning experience must be associated with making mistakes,
Right.
because you don't know the answer in advance. Einstein made a lot of mistakes. Anyone makes mistakes as long as you put yourself through the process of learning, because the whole idea of learning or discovery is that you didn't expect it in
That's right.
advance.
I always say that, if Einstein didn't make those blunders, Avi, he could have been a pretty famous guy. I mean, he might
Yeah,
have just been.
one thing that was raised against me was, oh, maybe Avi invented or is discussing Three Eye Atlas in this way because he wants to deflect attention from the Epstein files. There were some conspiracy theories
Yeah,
suggesting that. And obviously, I would be more powerful than the Pope if I could arrange for an object the size of Manhattan Island to exist at 4 times the Earth-Sun separation. That we know that's the distance
yeah,
because we had
yeah.
227 independent observatories around the globe. This is information that cannot be classified because there are so many independent people. You can buy half-a-meter telescope online and look at Three Eye Atlas. Like, this is not something that I can invent as a conspiracy. And so, when you explain that to people, they get it. And those that don't get it, they should consult their therapist about how to do better in life. And unfortunately, many people in the scientific community are not subscribing to the scientific approach of learning from experiment. We have a whole community in the leadership of theoretical particle physics, which is talking about extra dimensions, supersymmetry, things that were not proven, demonstrated, and they are doing it for 50 years. And if you do it for several decades, okay, but once you do it for your entire career and you don't have evidence for what you're advocating, you should worry about spending your life on just imaginary concepts that have nothing to do with reality.
How do we balance that though? Before we're going to get to questions from the audience because there's so many thousands of questions, but the kind of balance that we need to maintain as professional scientists to not fall into the trap of, well, because it's anti-orthodox, because it's counter expert or anti-authoritarian, it must be true. I'm thinking of, there's a tremendous amount of interest in kind of Alcubierre warp drives as explanations for how these objects, maybe even Atlas, use an Alcubierre warp drive, and then maybe it made use of the Byfield Brown effect and all this sort of nonsensical stuff that doesn't have peer review, that doesn't
Right.
have replication, that just has, kind of a lot of circumstantial evidence. Well, he was actually working at Northrop Grumman, this guy Brown, and then he actually, in Northrop Grumman, then they were related to the F-117, which was in Burbank, which is near Hollywood, and they had a soundstage. And then, well, Stanley Kubrick was working in Hollywood and also the NASA program. So, how do you balance the kind
Yeah.
of skepticism that every scientist needs to have about himself and herself, first of all, then everyone else in the scientific community, but then how do you avoid falling into the wormhole, the pitfall, the Alcubierre drive rabbit hole that leads you down to a pure conspiratorial endpoint?
Right. So this is an approach that I developed over decades. I've been practicing astrophysics for 4 decades, and here is what I learned: that it's worth spending your time on a hypothesis which really, solves a major anomaly that otherwise, there is no good explanation for it. So the community as a whole doesn't really find, a solution which is reasonable, easy to accommodate. And then there is no evidence that this solution is the right one. So if you are in this phase where there is a major anomaly that needs to be resolved, I think it's worth dedicating time, because it might be a new discovery. Okay. And however, if there are many things that are possible, and you can spend your life, we live for a short time, you can spend your life going down rabbit holes that end up being a waste of time. So you don't want that to be very often. So the way I do, I actually wrote an essay in Nature magazine in 2011, where I said, you think about it just like investing your money. You want to diversify your portfolio, maybe invest 20-30% of your research time in ideas that may end up not being right. These are risky propositions, sort of like investing in venture capital investments, and stocks, and then you should also allocate a major fraction of your resources to bonds, safe bets that are likely to bear fruits eventually. They are not as risky. They will not win you the Nobel Prize. Um, as to how much of your time you allocate to different levels of risk is a matter of taste. It's also a matter of which stage in your career you're in, because if you need to gain tenure, you must have something to demonstrate that you are leading a frontier, right? So it needs to be something that is popular, needs to be something that is appreciated, something that is not taking too much risk. But as you become tenured, that's the pathway for putting more of your resources in risky propositions. And it's a matter of taste, how much risk you wish to tolerate. What happens to most academics is that they invest, after they get tenure, they want to maintain their stature so that they get honors, awards, and never make mistakes. And that means they invest very little in any risky propositions. I don't have a problem with that, except that the whole idea of getting tenure was to allow yourself some job security, so you can take risks. And moreover, these people who become dogmatists, they not only do it themselves, but they ridicule anyone that takes more risks than they do, and they say bad things about those people. They write blog posts negatively, attacking me, for example. They make YouTube videos, and I say that that's a psychological problem that they have. You can select the level of risk in your own research, and let's just decide which hypothesis is correct based on data. Why do you need to ridicule or say bad things about the person who is taking more risk? It's just inappropriate. If you believe that these risks are not warranted, then don't follow them, and just prove that they are wrong based on data. That's it. You don't need to do more than that. You don't need to attack the person who takes more risk, because after all, these people who take more risk are the ones to pioneer new paths of knowledge.
Mm-hmm.
Einstein was not popular to start with until his ideas that were very risky got some traction in the community. So you
Yes.
want to allow, and I can give you examples. Like right now, I'm collaborating with a young fellow that was born in India, and he had to work hard to help his family, didn't have great grades, but I noticed that he's brilliant. And then I started collaborating with him. He applied to graduate schools, among them my own. And I know people in the selection committee that said, we don't want to take risks with a person who did not establish himself as of yet. I am working with that person now. He went to another university, and I can say this guy is brilliant. And unfortunately, such people at an early stage in their career, they can be easily sidelined because their brilliance is not recognized, their genius is not recognized, simply because the senior people who decide who should get into graduate school, who should get funding, who should get tenure, these people are so conservative that they don't appreciate innovation. You see, that's the problem, that you develop a culture of people who are looking for others like themselves that amplify their voice in those echo chambers that already exist within academia. So there are echo chambers, and you build up those echo chambers, but by finding people who say the same thing. And unfortunately, those people who take risks are underappreciated, even though they make most of the important breakthroughs.
And the thing that disturbs me most about the attacks that are made against you, it's always that there's a monetary component, and even that I'm funded. Perhaps you're funding me, or maybe Peter Thiel is funding both of us. I mean,
Well,
halavai, as they say, right? I mean,
Well,
no, he.
I just wrote an essay a week ago regarding that, where a few people approached me and asked me if I want to put my essays on Medium, which now get about 60,000 views
Oh
a
yeah,
day.
I'm putting
A
it on the
day.
screen now. I'm
I'm
putting it on
getting
the screen
I'm,
now. Yeah,
I'm getting 2 million views a month. That's just like a major newspaper. I'm just writing about science, and
yeah.
so many people are following me. So I was asked whether I want to monetize it or to put it under paywall. And I said, no way, because I enjoy communicating with the public without asking for any payment, and I will never do that. So I'm not making any profit out of my creative work. I
That
view it
reminds me, I have to do an ad now for shortform.com. No, I'm just kidding.
No, I see it as a work of love. Just think about it. If you love someone, you might give your body to that someone. But if you have to make money out of giving your body to someone, it's a very different experience.
That's right. That's right. And it brings up the world's second oldest profession. All right. We have, I'm showing the Trojan horse from your website. So everyone should go to Avi's Medium. It's free, as you heard, and it's phenomenal. And I get it every day. And then Avi's kind enough to send me emails, even though I get the Medium articles as well. So, Avi, we've got a billion questions. Let's take on a few of those before I have to break for Shabbat and then in 20, 30 minutes. Indy's Bike says maybe SETI can listen to Atlas to see if it sends out radio waves. It's kind of clever. What do you make of it?
No, that's exactly what I proposed in an email yesterday to people who operate radio telescopes. I hope they will do it. That's a great point. Yes.
Now, SETI Institute, do you feel like they would do? Because they seem to be kind
Well,
of a little
it's
selfish,
really it's really strange because for 60 years the SETI approach of looking for radio signals, which is similar to waiting for a phone call at home,
Yeah.
that approach did not yield any detection positive except for the wow signal that we just mentioned. And these people got used to the psychology of just saying we don't detect anything. So when someone says, oh, there is a different method that should be looked at that may detect something, they have a very negative response to that. So for some reason the SETI community does not really care much about detecting physical objects close to Earth that may have originated from extraterrestrial technological civilizations. Now, I say that because they ban any discussion on those objects in their conferences, and so
But
I
we
just
do
don't.
we do learn what will happen if we colonize it. If we have settler colonialists that go to another world, we have to be very much in tune with that, right, Avi? I mean, that could be a big danger.
Yeah, well, I mean, the way I think about an encounter with a visitor, a technological visitor from outside the solar system, is the way that ants, that are sitting in a crack in the pavement, are viewing a biker that passes by. I mean, I think that whatever we encounter would be so much superior to us because it managed to get to our backyard before we got to their backyard,
Yeah.
that we won't be able to communicate, we won't be able to easily understand the intent or the technology being used.
Yeah, I mean, probably not going to ask us for our preferred pronouns, those ants. Okay, we got a question here from Snares Tax. What do you think, Avi, of the chances that Three Eye Atlas breaks up as it goes by the sun? Obviously, if it was technological, probably be hard to make that argument. So, if it breaks up, would you then revise your priors on the nature of this object?
Yes, especially because we could see the pieces, what they're made of. They would, so as you make smaller pieces, they have a larger surface area per unit mass, and therefore they more easily get ablated. And so the fragmentation of an object, the breakup of an object, results in more and more surface area. Eventually, it's sort of like an explosion. That's why meteors burn up in the atmosphere, generating a fireball. So a similar process can happen close to the sun, and indeed would reveal that there is nothing inside. However, if it's technological, there might be a scenario where the object releases mini probes that visit the planets, because the object is moving, 3i Atlas moves on a retrograde orbit, which is opposite to the direction of motion of the planets around the sun. That's ideal for getting mini probes to the planets, because they don't need to chase the planets. They just go opposite to the motion of the planets and meet them, and then figure out
Mm.
whatever the purpose is. So I told the research team of the Galileo project that I'm leading to monitor the sky in the months after 3i Atlas passes close to the sun, to check whether there is any additional activity. But whoever asked the question is exactly right, that if the object breaks up into fragments of ice that get evaporated, then definitely
Hmm.
it's natural. Yes.
Okay, Jan Klaas asks, why not aim the Webb telescope at 3i Atlas?
Oh, it was on August 6th. The Webb telescope looked at 3i Atlas and got an amazing spectrum, because it has a large aperture, and you just need to look at the paper. The spectrum is amazing, and it
I'll put it on.
showed 87% by mass of the gas around the 3i Atlas being made of carbon dioxide, 9% carbon monoxide, 4% water. And since then, there were ground-based telescopes finding cyanide, as well as nickel without iron in the plume of gas. The object turned out to be green over the past month.
Mm,
We don't know why exactly, because there was very little C2,
methane.
two carbon atoms coming together in a molecule. There was very little of that, and that's usually what gives a green color to comets.
Mm. Okay, so next one question I have is coming from why should there be private companies? Why should this have to be privatized via the Galileo project? Although you are open to many different contributions, public and private, but why is this primarily taking place in the private sphere?
No, so the Galileo project, as well as much of my all of my activity over the past decade, was funded by either foundations or donations, and I prefer that mode of funding, simply because there is a lot of bureaucracy when dealing with federal institutions like the National Science Foundation or NASA. There are lots of reports you have to write. The application is very cumbersome, and that takes away from research time. And if there is someone inspired by the research, it's a much easier path to fund the research. And gladly, people were inspired. They came to my front door, billionaires that at my home, and offered the funding donations that support the Galileo project. And I also got contacted by foundations, and that's, for example, when I was the founding director of the Black Hole Initiative at Harvard. I managed to get the funding for this institute that was brand new out of foundations. We were funded by the Templeton Foundation, and later another foundation joined. And so altogether, it's an endeavor that is supported by now,
Yeah.
maybe at a level of 50 by the Gordon Moore Foundation. That was the second one,
Mm.
at the level of about by now $20 million over the past since 2016, over
And it's
almost a decade.
multimodal, it's multi-domain. It even listens and uses auditory bands to look for it. It's an ingenious endeavor, of course. I am not involved with it. People always ask me, "Well, you just love it." I briefly considered it, but I want to be impartial because I want to ask you difficult questions. I mean, we're good friends, but good friends, can have good arguments, all for the sake of heaven, as they say, but all for the sake of science. Okay, some people are telling me to warn you, Avi, that the government, if you find something, may attempt to do something to you. Do you have any, security concerns? In all seriousness.
Not at all.
Okay, good.
I think there is anything to do with objects from outside the solar system has no national security implications because, as I said, it affects all of Earth. And, we are all in the same boat, all humans on Earth. And I don't think one government or another can suppress the data because there are so many Galileos right now looking
Right.
at the sky, like amateur astronomers as well, that
Different
no,
countries. That's my
yeah,
argument against the, that's my number one argument against the fallacy of the moon landings, that they actually did occur, is that the Soviets witnessed that landing occur and they would have had every intention and every motivation to prove that the US failed and that the astronauts all died on impact. Okay, more questions. David Drennan asks, if Atlas is an engineered object, would you expect its trajectory, its mission profile to look like a passive reconnaissance energy harvesting payload release? Could any sort of technology leave a footprint that would be observable? I think it's a lot of things
yeah.
mixed in, but yeah, what would you expect it to leave behind as a detritus, as
Well,
the detectable detritus?
and another way to ask this question is what would be technological signatures of a spacecraft that makes it different from a rock? Okay, and one would be maneuvering. As I said, there is no detected non-gravitational acceleration for 3I Atlas so far. So if we see a huge maneuver, it would mean that it has nothing to do with cometary activity. It must be some engine that allows it, a propulsion system that allows it to do it. The second thing you can think of is transmission of signals, like I mentioned before, the WOW signal, or if radio observatories detect radio emission from a comet, we don't expect that naturally, especially not in a narrow band of 21 of the hyperfine transition of
Mm.
hydrogen. And then you can imagine some excess heat. If there is light that is artificial coming from the object, has nothing to do with the illumination by the sun, that could be a technological signature. There are many if we have an image that shows that the object has a structure that is not a rock, if we land on it, we can easily tell that it's made of screws and bolts on the surface, that it has some buttons that you can press, that these are signatures that cannot be mimicked. But I say, even if it's a rock that came from interstellar space, if we ever land on such a rock like 3I Atlas, that's an amazing opportunity to bring back materials like, let's say, 100 grams, as we brought from Bennu, the asteroid Bennu from the solar system, and examine those materials to see if there are the building blocks of life as we know it. And this is a completely different approach than looking for the chemical fingerprints of microbes in the atmospheres of exoplanets. That's where the mainstream of astrobiology wants to invest more than $10 billion, the highest priority in the decadal survey of 2020. And
Mm.
I say, here is another alternative approach for astrobiology. You actually retrieve materials from the environment of another star, and you learn about the building blocks of life there. And it would take us millions to billions of years to reach those other stars with spacecraft and bring back the material to Earth. Instead, you have an object that made the trip already over millions to billions of years. And all you need to do is just land on it, retrieve the material, bring it back to Earth. And this is a frontier of astrobiology not recognized at all. If you ask practitioners in the mainstream of astrobiology, they would never bring it up. And I'm
Right.
saying, after 3I Atlas visited, we should consider that even if you believe it's a rock, it was an amazing opportunity. We don't have an interceptor that could meet it, and we should design an interception. We can have an array of interceptors. Whenever an object like that comes along, we just cross its path and land on it, bring materials back to Earth.
I want to ask you about a strange confluence. I want to add two more anomalies to your list of, what did you say, seven, Avi? One is that it's coming closest to Mars, the red planet, on the 80th anniversary, 70th anniversary almost, of 68th anniversary maybe, of the Sputnik launch in October, which itself was 40 years after the Red October incident of the Russian Revolution. A lot of these things are happening, and that's when it gets closest to the red planet. anything to be had from this, or do I have a tinfoil hat I need to replace my dunce hat with? What do you think
Well,
about this? My
we have to
unicorn.
keep in mind, we have to ask when did it start its path in this direction? And
Yeah,
80 years ago, it would have been around the Kuiper Belt. So if there is a camp over there where they decided 80 years ago to send a probe, then that's the time when it would arrive right now. And uh, we keep talking about the outer solar system, how little we know, whether there is another planet out there. There was
right.
recently a discovery of a new planet that disproves perhaps the planet 9 hypothesis, because it's completely in a different direction
Uh-oh.
from it. And and it wouldn't exist. It would have been liberated from the solar system if Planet 9 existed. Anyway, there is this dispute about Planet 9, but there was a new planet discovered. And my point is, imagine that there are some spacecraft parked or orbiting the sun in the outer solar system. We would never know about them because they don't reflect enough sunlight, even if they
Yes.
are tens of kilometers in size. And when we see anomalies in the outer solar system, we would try to explain them in terms of natural objects. So, we are too ignorant to be dogmatic. That's my point. There is no reason for us to resist the idea that there might be technological artifacts heading our way, because we don't know how near are such objects to us
Mm,
as of now. And there is this dark forest hypothesis that they might come to visit us when they realize that we develop technologies that might be of risk to them, because we
that's
can
right.
notice them. And so in a dark forest, you prefer not to make a sound until there is a threat. You are afraid of predators, but once you observe potential predators, you go and visit them, and that may be through eye atlas, for example.
And then the other anomaly for the ninth one is that it is the government shutdown has occurred. So the aliens have timed things rather exquisitely. But I actually want to ask you about a conversation I had with,
Well, just on that, Brian, before we continue, I
yeah,
would say the shutdown is a reflection of human stupidity, not of extraterrestrial intelligence.
amazing, Avi. Okay, so I talked with Commander Chris Hadfield. It's coming out on Tuesday or Wednesday when his new book comes out called Final Orbit, the third in the Apollo Murders trilogy so far, although he's going to write many more. And we're talking about this battle. It takes place during the Apollo Soyuz era when there was cooperation between governments, like cooperation between the Soviet Union and America. And then, things went really well at the end of the Cold War. Now things look pretty horrible. And the kind of the stealth character, it's not really a spoiler because it plays such a big role in the book, is a Chinese scientist who Tianchu Liu, I think is his name. He went on to become the father, the Werner von Braun, but not of America, but of China, and established their nuclear program and their space program. And we talked about kind of the new era of perhaps space warfare, and that might be an answer to the dark forest, or alongside the dark forest, the technology that might be coming out, and perhaps traveling across the solar system might not be friendly. It might be kind of perhaps you would call them migrants coming to
Yeah.
another world. What do you
Well,
think about this? The
yeah.
Chinese, and where are the Chinese with respect to America? Because I see the Russians rather, as far out of the game in terms of investigating scientifically. They've been ostracized. The Chinese are on the rise. What do you make of them and their search for extraterrestrial intelligence as well?
Well, they have, of course, now the biggest radio
Yeah,
telescope that replaced
five
Arecibo.
hundred meters. 500
Yeah,
meters.
and they define the search for radio signals as an important priority. But studying objects, like Three-Eye Atlas or other interstellar objects, they're still behind. For example, they don't have an equivalent to the Rubin Observatory that was funded by the National Science Foundation, Department of Energy. So we still have an edge on this part, but they're really into space as a matter of their own pride. And one thing that is of greatest concern for the superiority of American science is that they have a plan to send a sample retrieval mission to Mars, because recently NASA announced that there might be evidence for microbes on Mars based on the spots that were identified on the rocks at the Jezero crater. And actually, the Chinese have a plan by 2028 to send a sample return mission to and bring back the sample by 2031, and they might actually do it before the US. And if there is evidence for life, they might be the ones to discover it. So there is a race as to finding extraterrestrial life, and it's possible that the Chinese will do it earlier than NASA, simply because NASA is slow in funding the sample return from Mars. And I think that will be quite unfortunate, because the preliminary evidence from the Perseverance rover was quite impressive. The other thing, is that we should obviously consider, the existence of alien technology as something that should bring all humans on Earth to be engaged in the search, and that's the nature of science. Although it's being used for political purposes, I think it would be nice if we coordinated and helped each other across the world in advancing this frontier of interstellar science, and that is what I advocated to the United Nations.
Mm-hmm. So we're going to wrap up in a few minutes, Avi. There's a question again from David Drennan. Given that JWST showing the ratio of carbon dioxide to water is 8 plus or minus 1, how do you reconcile the expectations for a technological object? Could it be an engineered probe?
Well, so that's the ratio in terms of molecules, but the ratio of production rate of molecules of carbon dioxide versus water. But if you take the atomic weight, the weight of each molecule, you find that water makes only 4% of the mass budget, and carbon dioxide makes 87%, and carbon monoxide 9%. So water is much less significant in the mass budget, and that goes against the conclusion that was drawn by many comet experts early on. When 3I Atlas was discovered, there was a very strong statement that it must be water rich, which is similar to comets from the solar system. And then there were a couple of teams that claimed, we detect water, it is water rich. And I looked at the data. It was very noisy in one case, and it was exaggerated, inappropriately analyzed in the second case. And I criticized those statements that it's water rich. And I was attacked personally for making some critical remarks about the conclusions of these two papers. And then came the Webb telescope that measured very accurately the level of carbon dioxide and water. And it turns out that indeed carbon dioxide is far more important in the mass budget. Now, to your question about what does it mean, is it natural or not? As I said before, the amount of mass being released, if you split it across the surface area of an object that is 5 to 46 kilometers in diameter, you get a very thin layer of the object, less than a millimeter, being ablated over a period of months. That will account for all the mass that we see. So it's very easy to see the cometary, the coma around the object, even if it's very dilute. And it is very dilute. I say, if you sum up all the mass that was lost by an object with 150 kilograms per second over a period of several months, and you share it across a surface area of such a giant object, you end up with a layer that was ablated that is less than a millimeter thick. It's nothing compared to the size of the object. So what lies inside is a different matter, and it could be just the outer layer of even a technological object. That's why I'm saying, if it breaks up, then obviously it must be natural.
So, Avi, one last question comes from Steed, who looks an awful like my friend Terrence Howard. I wonder if that is Terrence. Not Terrence Tao. He'll be on the show coming up very soon. Reminder for everybody before we wrap up, and the final very provocative question. You can get a meteorite if you're one of the lucky winners Every month I give out a couple of dozen of these beauties here. This is not an extraterrestrial technology, but it's extraterrestrial metal, older than our solar system, right, Avi? It had to come from a star, maybe beyond. It has a lot of cobalt, nickel, but not in the ratio that Atlas has. So you're lucky to win one of those babies, but you're guaranteed to win one if you have a .edu email address like Avi and I do. And that's if you live in the United States. So go to briankeating.com/YT or /edu. And last thing is, I hope everyone will pick up a copy. Next week is Christmas for Nerds, Avi. It's the Nobel Prize season. A reminder, my 4th book is out, Into the Impossible, volume 2 of my interviews with Nobel Prize winners. And these include some of the most phenomenal minds on planet Earth, or perhaps even beyond, including astronomers. And maybe, I don't know, Tuesday, are you going to stay up late Tuesday, early Tuesday morning, Avi, or what are your plans for late Monday night, Tuesday morning when the physics prize gets announced?
Um, I already said that I would take the approach always of Bob Dylan, that didn't care much even after he was awarded, not to speak before,
Yeah.
because life is too short for us to waste it on getting approval from other people. Why should we worry about the recognition that we get? Let's just do what we are passionate about. That is the best recipe for good life. And I learned it, by the way, when I was a kid on a farm. And I enjoy going out every morning in the company of ducks, bunnies, rabbits, wild turkeys, birds, because nature is much more imaginative, much more enriching than whatever people can give us. And so I don't really care about prizes. That's really second. Yeah. At
Yeah.
this point, when I was younger, it really was very important for me.
Yeah, I mean, the only metal that we should really care about is, what is this thing made of? What is the extraterrestrial metal on this object called Atlas? And then the last thing, just before we wrap up the show, is the request, the very humble request that I have, that people will go to this website for the Signal Awards. It's not the Nobel Prize, but it's given on the same day. And that is to help me win a podcasting award, which I've never won before, but I have to be in the top. I think I have to be in the top 3 to actually win. I'm only at 13%. Come on, everybody out there, please go to the link in the pinned description and in the pinned comment on the side. Click on that. Vote for Brian Keating. Into the Impossible. Interview with Mike Brown about a trans-Newtonian object, or possibly Planet 9. This potentially could win a gold medal, if not a Nobel Prize. So link is for the Signal Awards. You can only vote if you have a verified email address, so you need that. We have 2 more questions to come. One is, why aren't we sending signals, or are we sending signals, or should we send signals to 3i Atlas? Something like the Voyager record, or beam something to it. What would you think about the wisdom of that being asked?
Well, that's an excellent question, and obviously, if it's a technological object, they're aware of all the signals that we've been broadcasting for a while, because we were not careful. We were playing it dumb. We assumed that there is nothing out there, and if we transmit some signals, the question is, will they serve any good purpose? I mean, maybe we'll get a response. It's a way to start a conversation. We can say hello, welcome to our backyard piece, or something like that. But the issue is, first, they will not necessarily understand it. Second, they might interpret it as a hostile message. Who knows? And so my approach, in a blind date, there is always the concern that the person that you are dating is a serial killer. Right? You don't know if the person is friendly. Of course, if you're an optimist, you go on blind dates and never assume a serial killer. But I'm just saying, there should be an organization, international organization, that will decide how to respond. And that includes what we transmit, what we do in response. Just like in any other black swan event, we need to have some policy here. And it's not a matter of a single person to decide. It's because it affects all of us, all humans. We're all in the same boat, and if someone rocks the boat, we can all disappear. I don't think the universe cares much about humanity, whether humanity exists. It just came along over the past few million years. The universe existed for 13.8 billion years before we came to exist. And if we disappear, I'm sure that we have siblings on near other stars. Nobody cares if we exist or not. It's just a matter of us preserving ourselves. It's survival. And the best way to survive is to be smart about how you interact with threats, with predators. And I think we need to have an organization that decides about it. It's not a matter of a single person making a choice and bringing all of us down the drain.
Absolutely. Well, Avi Loeb, this has been a wonderful way to start the new season of the Into the Impossible podcast. As we go into it's my 8th anniversary on YouTube. Of course, I took the first 3 years off. I didn't really do much, and that was because I was too busy promoting my first book. And I had some guests on, of course, but not at the level of taking things now. So please do subscribe to the channel, leave a comment, leave a like. Let me know what you want to ask Avi when it comes closest to the sun. Is that on Christmas, around Christmas, Avi?
No, October 29th
Oh,
is when
29th.
it's, yeah, so we just have another month to wait.
Okay.
Not too long, and then we might see fireworks and celebrate that it's just a rock. That would make me happy. There is no threat to humanity. On the other hand, I do think we need a wake-up call, because we are focusing on the wrong things, on conflicts. The and I'm worried about a civil war within the U.S., given the polarization, given the fact that we see gunshots, aiming from one side to the other. That's very dangerous, and we could be aiming, going into a civil war. And it's also true globally around the world. So we really need desperately a wake-up call that we should change our priorities. And I feel sometimes like I'm in a, when I read the news, that I'm like in a party where the party goers are misbehaving. And the best thing I can hope for is to look through the window and look for a new guest that will show up and make the situation better.
Well, I second that emotion. I always say that, astronomy is always a safe space because, well, I used to say nobody looks up at a constellation and says that's a Republican constellation and that's a Democratic asteroid. But nowadays, who knows? They might really politicize outer space.
Well,
Avi,
3i Atlas started red, then it turned green. So I don't know if
uh-oh.
you. And I asked Representative Luna. I said, "Do you think that represents political views?" And she declined to answer that.
Yeah, I mean, red and green. That could be Greta Thunberg. Let's send her on a float. Let's send her on a flotilla to Comet 3i Atlas. I'll even give her some freeze dried ice cream. Avi Loeb, thank you so much. Shana Tova, Shabbat Shalom. Thank you so much for everything you do, keeping people interested in science, communicating what you do, not taking money from the public, giving things back, in fact, for free. Takes a lot of your time, a lot of your effort, but I know you love it, and we love you too. So please go to Avi's Medium. I'll link it down below. Sign up for that. Make sure you get it. Leave him some applause. If not, he doesn't request any financial remuneration. And for me, I do, because I'm shameless, kind of plugging. I want you all to have extraterrestrial technologies. You might win one, a meteorite, fragment of an asteroid. Pick up my book, my latest book. It's a labor of love. I lose money on every copy, but I do want the wisdom. The focus, Avi, the focus of these Nobel laureates is unparalleled. Even though we don't love the prize as much, maybe, the people who win it, they have no choice in the matter. They get nominated, they win it.
Well, I already got my biggest reward, and that's this girl that decided to do science as she grows up, inspired by seeing a television interview that I had. What can be better than that? Like, I mean, who cares about a piece of gold? Like, if you make a difference for the life or the career choice of a young person,
Yeah.
that's bigger than anything.
That's a whole world. You opened up a whole universe to other people. And that's why we do it. And that's why I actually chide my fellow professors and scientists who all they do is take pot shots at people like you and sometimes at me and other people that I care about who do things, we don't get paid. There's no pot of money coming from, St. Peter Thiel or whatever the nonsense BS conspiracy theorists. I'm a public school university professor. Avi's, at a private school, but he does what he does for the public. He discloses
But
everything.
one thing I wanted to add is, it's really important to play chess rather than wrestle in mud. Mud wrestlers get dirty. And so if someone attacks you, someone is doing the unreasonable thing, just ignore it. Don't get dirty, because that's what they want, to bring you into the mud. They are jealous. at whoever is playing chess. And I just decided to avoid any conflicts of that nature.
That's what they say. Don't wrestle with pigs in the mud because the pig gets you get both get dirty, but the pig actually enjoys it, Avi. That's the shameful thing. Okay, everybody, thanks so much. Don't forget to vote for Into the Impossible at the Signal Awards. It's the only thing I'm asking. All I do is basically give away stuff. So hopefully you guys will like it. Leave a review if you've gotten the book. And stay tuned. The next couple of weeks are going to be huge, Avi. We've got, as I said, Dr. Lou Ignaro, inventor of Viagra, won the Nobel Prize, saved countless lives. That's exactly what Alfred Nobel wanted. You know, it was very pure. He wanted discoveries and inventions that would improve human life. The X-ray, the very first X-ray, the MRI, the CAT scan, the CCD camera, and discovery of things that are not immediately relevant, like an extrasolar planet or perhaps someday an extrasolar piece of technology. So that's coming Monday. Next Wednesday comes Commander Chris Hadfield, Major Tom, Space Oddity. He's coming on the podcast and for his new book. And we've got a huge episode with Terence Tao, one of his first and only interviews with a legitimate professor and scientist, if I can call myself that. Fabulous 3-hour interview. We also talked about things like Harvard and UCLA getting funding cut from the Trump administration. You don't want to miss that. It's really one of my most beautiful cinematographic episodes ever. And Yom Huleda to me, happy birthday to the podcast on the 8th anniversary. Everybody, thank you so much. Avi, Laila Tov, thank you so much.
Thanks for having me.
Bye, guys. Bye, everybody.